This is problem number 6 from the Chapter 8 review. We're going to go ahead and solve a system of inequalities. So first thing we're going to do here, I'm going to do these in different colors. The first one is y is less than the quantity of x plus 4 squared minus 6. Okay, so things that we know about that already here, right, is this is going to be a parabola. And we're talking about it's less than, right? And it doesn't have the less than or equals, so we know this one is going to be dashed. And we'll talk about the shading here in a moment. Our second one, right, when we look at this, we know that this one is going to be a line. We have y is greater than or equal to negative 2/3 x plus 2. So the shape is a line. And in this one, because it has the equals sign under here, right, this one we know is going to be solid. So let's go ahead and put them on here first. So for our y is less than the quantity of x plus 4 squared minus 6, right, our vertex here is going to be at negative 4, negative 6. So going back to the left 4, let's see, 1, 2, 3, 4, down 1, 2, 3, 4, 5, 6. So there's our vertex. It's got standard growth. So remember, we're over 1 and up 1. Holy cow, I went up 2. So over 1 and up 1, reflect it. Over 2 and up 2 squared would be 4. Reflect that. If I go over 3, we're going to go up 3 squared, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. So it looks like the y value would be positive 3. And then I'll also go over and reflect that across here. And, if you wanted to go up, one more, you could get an accurate y-intercept there. I think the y-intercept actually ends up being up here at 10. So I'm going to go ahead and just mark that there. I'll mark this one over here. And then we'll just take this and we'll sketch it in with a dashed line, remember, because it doesn't equal these. These are boundary points. So it's dashed all the way through here and continues on that direction up there. Okay, now when we're talking about the shading, remember if you took your marker and you put it on like the vertex here, right? So everything above the vertex would be greater than our outputs, and everything below would be less than, meaning the y values would be less. And we're looking for where the y's are less than this boundary marker we've created. So the shading we would end up with here, right, would be outside of this one. Okay, now you don't have to shade it right now. You can come back and shade in just your answer in a little bit, but I just want to make sure that it's clear for everyone. That's nice and pretty. All right, so let's go ahead and let's look at our second one here. So we had y was greater than or equal to negative 2/3 x plus 2. Our y-intercept is at positive 2. We've got a negative slope, which means we're going to be going, like down 2 and then to the right 3. So I'm going to go down 2, right 3, down 2, right 3, down 2, right 3. And then we can go, up 2 and then to the left 3, which is just the opposite direction. And now we'll take this here, and this one should be a solid line. So we'll take it here and graph it in there. And since we're looking for all the y values that are greater than, so all the outputs that are greater than that line, so you have the y values for that line, they're right on it there. So everything that's going to be greater than that line would be above, right? So you'd be thinking it would be everything above the line. So as we're looking for the solution to this system here, let's see here, if I took it here, right, I don't want to color all over everything, but I'm going to be looking for my pink will be the solution for all of it, right? So notice here, this is actually, let's do a marker. So this here would be solutions to both of them, right? Everything above the line. And is there anywhere else? There actually is. Right over here, you see they start to overlap again there. So this would also be everything outside of the parabola that is above the straight line are our solutions. Now, to check it, right, let's check it here. I can take a value that is in that shaded region and I can plug it in. Let's say, here's an easy one to recognize. Let's do the point over here. This is the point 10, 0, right? The point 10, 0. Our x is 10 and our y is 0. Let's just take it and plug it in to make sure everything checks out. So I'm going to put 0 is less than 10 plus 4 squared minus 6. 10 plus 4 is 14. 14 squared is 196. Minus 6 is 190. 0 is definitely less than 190. And then let's plug it into the second one. We've got 0 is greater than or equal to negative 2/3 times 10 plus 2. Well, we take that and we multiply it out here. We could do negative 2/3 times 10 would be negative 20/3 plus 2. And if we look at that there, that's like negative 20 over 3 plus 6 over 3, which is going to give us negative 14 over 3. And it doesn't even matter what that exact value is. We know that that is a negative number, so it is definitely less than or equal to 0. So 0 is greater than or equal to that. So we have checked it there, and it definitely works. So don't forget to check these. I mean, these ones are easy to make a little goofy mistake. If you've forgotten graphed something wrong, maybe you put a negative slope in where a positive slope is, or vice versa, accidentally flipped a parabola, shaded on the wrong side. This is a way you can check it to find your mistake. All right, so this is problem number 6 from the Chapter 8 review. Let me know if you have other questions.